Okay, so we've got an object which is in equilibrium on an inclined plane, and it's not moving. We've got this force F here, sort of holding it in place. So the force F is parallel to this inclined plane, acting up the plane, to just keep that object in place, to stop it from sliding down the plane. Now, of course, we need to know the angle of inclination, and they've given us angle alpha here, and they've told us what alpha is in terms of a ratio, okay, of tan alpha. So we're going to work out what sine alpha is and cos alpha directly from this, okay? And to do that, what you should do is draw a right angle triangle, okay? Because sine, cos, tan, all to do with triangles. And of course, if I put alpha here, okay, then we know then that this side is the hypotenuse, yeah, the longest side. Then of course we've got the opposite here, which is opposite the angle, alpha, and then we have the adjacent here, okay. Now, if you look at the fraction we've got here for tan, 12 over 5, well, if you remember tan, it is opposite over adjacent, yeah, okay, over A, so that means the top value there, 12, is the opposite, okay, so we can write 12 there, and the denominator here, A, okay, that value there is 5 in this fraction, okay, so we know what O and we know what A is. In order to work out cos and sine, I need to determine what H is. And if you do a little bit of Pythagoras, okay, square that side, and of course add them. So the sum of the squares of both smaller sides. And then if you square root this, it comes out nicely to be 13. So the hypotenuse is 13. So from there then we can work out what cos alpha is. Remember now, cos alpha is adjacent over hypotenuse, so that will be 5 over 13, and then sine alpha is opposite over hypotenuse, so 12 over 13. Okay, so those are the values there for cos and sine. So we don't actually have to work out the angle alpha, we don't need to work it out, we just have these fractions here for the values of cos and sine. Okay, so let's look at the diagram itself, okay, and what I have you to do here with this reaction here, which is sort of perpendicular to the plane, get your ruler and continue then, okay, with that line, broken line there, okay, and we'll also do a broken line down the incline as well, okay. So then if you turn it around, you've got your cross situation, haven't you? Your x sort of direction and your y direction, okay? So your x direction is parallel to the inclined plane and the y direction is perpendicular to it, okay? And the good thing is there, what we should remember is then that this angle here is alpha, okay? Because of course, just looking at triangle, the idea of triangles here, if you think about it, that's a triangle, so that would be right angle. So this angle here would have to be the complement from 90 from this. So basically 90 minus alpha, this would be, okay? This would be 90 minus alpha, which means this is alpha. If you put numbers in, it's much easier. So if that was 30 degrees, that would be 60 degrees, which would mean this is 30 degrees, okay? Because that's a right angle. So that angle is the same there, okay? Now when I turn it then into the cross situation, we can then resolve, because that ATG is sort of going in that direction. Remember then you've got to get sort of in that direction, you've got to go across the corridor, down the stairs. So across the corridor would be in that direction, down the stairs in that direction. Now, because the alpha is to this side here, okay, this side contains this angle, so we're going to put cos here. So that'll be ATG cos alpha, okay. And then of course then down here, going across here would be sort of like this direction, which is opposite the angle alpha. So this will be ATG sine alpha, okay? And then because it's in equilibrium, okay, well, when we, again, looking at the cross situation, the up equals the down, so to speak, yeah? They've got a balance, and then the left equals the right. So if I look at this direction, R has got to equal ATG cos alpha, yeah? Okay, when we resolve, so resolving in equilibrium, when the system's in equilibrium, we can say R is equal to ATG cos alpha. Okay, now of course, good thing is well, G is 9.8, and cos alpha, we worked it out there to be 5/13. Okay, so you literally get your calculator, and we've got the answer straight away. That comes out to be 301.5 newtons. And then, so that's resolving sort of, that's resolving perpendicular to the plane, isn't it? So if I've got that there, we're kind of resolving in that direction, aren't we? Perpendicular to the plane. And then if I resolve parallel to the plane, so going in that direction, well, we've got F then has got to equal the ATG sine alpha, yeah? Okay. They've got to balance each other because it's in equilibrium. So 80 times 9.8, and sine alpha we worked out before to be 12/13. So my calculator, I've got 723.7 newtons.